Hello, my name is Faisal, and I'm going to present about the proposal which states that image reconstruction of muscle fatigue for simulated electrical impedance tomography. Now, this is the overview starting from introduction until conclusion. And in the introduction, we have the definition of tomography, which is a technique of reconstructing cross-sectional images of objects by using waves that pass through, bounce back, or scattered from the object. Among the most significant thing about this technique is that it can be used in medical monitoring, such as monitoring for internal bleeding, screening for breast cancer, like the mammogram, detecting pulmonary emboli, and detecting blood clotting in the lungs. In the problem statement, as we all know, people these days they want to be fit and have a healthy lifestyle, and because of this, they would do exercises. Now, the exercise will have two regimens: strength athletes and endurance athletes. And in these two athletes, they have something in common whereby the athletes will become worn out due to muscle fatigue. And in the problem statement, as we said before, the athletes will experience muscle fatigue, but because of that, they would either would continue working and ignore it, or have some problem with that muscle fatigue. Because of this, the project will use tomography image reconstruction to visualize the muscle fatigue and give a sort of advice or suggestion to the athlete either to rest for a longer time, or if it is serious, to be taken to a physician for health attention. Now we have research objective where we start with to establish COMSOL simulation for muscle phantoms using finite element method to reconstruct tomogram images of fatigue muscle using PYEIT and ENDO software, and to perform image quality assessment for reconstructed images. Here we have scope of study where we use the algorithm that can read the data being created from one of the tomogram techniques. And this data will be beneficial to us as that it will use a tomogram image with the color range in detecting the amount of fatigue in the muscles. Based on these results, the image will be analyzed and propose the best approach for reducing muscle fatigue to the athletes. The significance of the study is that it uses the study of the image being processed and will be given to physiotherapy in order to either improve the athletes in terms of their performance in the exercise, and also to avoid any sort of sports injury and give them any rehabilitation activities. And now we go to the literature review. We start with the skeletal muscles, where it is attached muscles that attach to the skeleton, and they're responsible for body movement. They have something called muscle fiber, which are the functional cellular unit of skeletal muscles. Actin and myosin filaments, which are mostly inside the muscle fiber, are constructed together to form a sacrum that controls the contraction and the force of the muscle. And we have neuromuscular junction, where this is a junction between the nervous system and the muscle. The nervous system will create some signals to the muscle system either to contract or relax. And then we have muscle fatigue, whereby this is a force output, and it is reduced due to over exercise resulting to the muscle fatigue. And to detect this muscle fatigue, normally we will use physical metrics like twisting torque and maximum force that will be used. Different events can cause muscle fatigue, from metabolize in the muscle fiber to insufficient motor commands coming from the central nervous system. And then we have types of tomography. We'll start with fluorescent molecular imaging, which is a technique to visualize and quantify the distribution and dynamic specific molecules within the living organism. And then we go to electrical impedance tomography, which is a non-invasive image technique that allows for continuous real-time observation of the distribution of dynamic electrical conductivities throughout the body. And this is the type of the tomography that will be used in the project. And then the last one, we have a project data collecting method called parallel beam geometry tomography. It uses a parallel transmitter and receiver, meaning that the parallel and the transmitter and the receiver are in the opposing side, creating reconstructed images. In this approach, object attenuation weakens the signal that is being sent, and mostly this is implemented in CT scan and MRI and also PET. Now we go to PYEIT and ADOS. PYEIT is an image reconstruction software in EIT that uses Python interface as a base to work on. And then we have EDOS, or Electromagnetic Inverse Domain Reconstruction Software. It is a collection of free software-supported image reconstruction under MATLAB software. Now, comparing it between the two, PYEIT lacks some functionality like total variation TV regularization, complete electromodel regularization. However, PYEIT is expandable and developed in Python. PYEIT can use these missing functionality as a plugin where you can download the functionality and plug it inside the Python interface. And as well, these days, as we all know, all devices or softwares are using Python, which will be easier for using PYEIT in this project. And we have image quality assessment. Here, image quality assessment is a method for evaluating the degree of accuracy for a single image. It has different metrics like mean square error, peak signal to noise ratio, and signal to noise ratio. MSE value shows the difference between the original and the processed image. PSNR creates a ratio between the two pictures in decibel, thus showing the quality of the processed image. And the last one we have SNR showing how much noise is present in the processed image as compared to the original image. Now in the methodology, it is divided into two parts. One is the data acquisition phase and the other is image assessment phase. The data acquisition phase will all be implemented in the COMSOL software, and it is used to create the data. Now here we start with creating a finite element setup where it creates all the 16 electrodes around the subject, and then create the electrical waves, and then establish geometry modeling of muscle fatigue. We create the modeling of the muscle and having the fatigue in the muscle, and then we run the simulation to get the data. We save the data and upload it to PYEIT and ADOS. In the image assessment phase, we set up the image reconstruction algorithm in both of the softwares, and then identify if the image reconstructed of the muscle is in fatigue condition or not. If yes, then it continues to the next stage. If no, then it goes back to the data acquisition phase. And then afterwards, it will perform image quality assessment in order to assess the processed image if the quality is high or low. And then here we have results. This is expected results, and it is mostly from a bicep muscle taken from previous papers. The left here is the muscle that doesn't have any fatigue condition. The middle is after exercising the muscle. You can see here it is developing some sort of muscle fatigue, which is the red color. And after 15 minutes of exercise, the muscle fatigue will be grown excessively. In conclusion, I can say that this project will help the athletes to reduce their muscle fatigue and effectively avoiding any sort of sports injury. Thank you.